All right, let's talk about a single word. It's a word you hear thrown around all the time, but it just might be the most misunderstood and honestly the most powerful word in the entire vocabulary of science.
I'm sure you've heard this before, right? Or something a lot like it. It's a classic line of argument, and on the surface, it kind of makes sense. It sets up this battle, fact versus theory, as if a fact is rock solid and a theory is, well, just a flimsy guess. But what if I told you that's completely backwards? What if a scientific theory isn't a fragile guess at all, but the absolute pinnacle of scientific achievement? Let's unpack that idea with one of the most incredible stories in all of modern science. So, our story doesn't start in some fancy lab. It starts inside the mind of one person, Albert Einstein. And he had an idea that was, well, truly mind-bending.
Picture this. It's 1915. Einstein has just published his theory of general relativity, and in it, he makes this wild claim. He says that space and time aren't just an empty void, but a real physical fabric. And he predicted that huge cosmic smash-ups, like two black holes colliding, would literally send ripples through this fabric, kind of like a bowling ball dropped on a trampoline. The only catch? Even Einstein himself was convinced these ripples would be so tiny, so faint, that we'd never, ever be able to detect them.
Now, in the language of science, what Einstein had right there, that's what we call a hypothesis. This is the word that really means an educated guess. It's a specific, testable prediction that you can go out and try to prove or disprove. Einstein's prediction of gravitational waves was a brilliant hypothesis, but for the moment it was completely unproven.
And boy, did that hypothesis kick off a hunt. We're talking one of the longest, most difficult, most ambitious quests in the history of science, trying to build a trap for a ghost.
I mean, just look at this timeline. The sheer scale of it is staggering. This wasn't something they figured out over a weekend. From Einstein's idea in 1915, it took generations of scientists pioneering new tech, finally leading to the construction of an unbelievable machine in the 90s. And then, a full 100 years after the prediction was first made, they finally found something.
And this is the machine they built to do it. It's called LIGO. It's not just one observatory, but two of them, working together in perfect sync, thousands of miles apart. Each one is this massive L-shaped detector with arms that stretch for 4 kilometers, designed for one purpose, to catch the tiniest possible shimmer in the fabric of spacetime.
And when I say tiny, it's almost impossible to get your head around how small. For this whole thing to work, LIGO had to be sensitive enough to detect a distortion in space that was 1/10,000th the width of a single proton. I mean, just think about that. It is one of the most precise, most delicate measurements humanity has ever even attempted.
So, after a century of dreaming and decades of building this incredible instrument, all the scientists could do was wait. They had to just sit and listen for a whisper from the deepest parts of the cosmos.
And then, it happened. On a September morning in 2015, they got it. A signal arrived, perfectly matched in both detectors. When they converted the data into sound, it was just this tiny little chirp. It was the echo of two massive black holes that had spiraled into each other and merged into one, an event that happened 1.3 times billion years in the past. Okay, so this brings us to another one of those really important words, a fact. In science, a fact isn't an opinion or a belief. It's an observation of the world that has been tested and confirmed. Over and over again. It's raw data from the universe. So, that little chirp that LIGO recorded, that, my friends, is a scientific fact. The instrument observed it. Thousands of scientists pored over the data and confirmed it. It absolutely happened. It's a solid piece of data that nobody disputes. And this is where it all comes together, the word theory. And look, in science, a theory is not a guess. It's pretty much the polar opposite. A scientific theory is a huge, powerful framework built on a mountain of evidence that explains the facts and predicts new ones. It is the absolute highest level of certainty in science. And our story illustrates this perfectly. It was Einstein's theory of general relativity that gave us the hypothesis of gravitational waves in the first place. And when the fact, that little chirp, finally arrived 100 years later, the signal matched the predictions of his theory with breathtaking precision. The theory wasn't a guess. It was a roadmap to a treasure we didn't even know we could find.
Okay, so proving a 100-year-old idea from Einstein is awesome, but so what? Why does this actually matter to us today? Well, it turns out it changes pretty much everything about how we look at the universe.
You see, detecting that first chirp wasn't the end of the story. Not at all. It was the explosive beginning of a whole new way of exploring the cosmos, a brand new field called multi-messenger astronomy.
Think about it like this. For all of human history, we've only had eyes. We've only been able to see the universe with telescopes that collect light. But now we have ears. We can actually listen to the vibrations of space-time itself. We can hear a black hole collision and then point our telescopes to see the afterglow. This lets us do incredible new things, like pinpoint the cosmic forges where things like gold are made, measure the expansion of the universe with incredible accuracy, and test the laws of physics in ways we could only dream of before. A powerful theory doesn't just explain the world, it unlocks it.
So the big takeaway here is really understanding how these words, hypothesis, fact, and theory, all fit together. Because when you get it, you really understand how science works and how it gets stronger over time.
It really just boils down to this. When someone casually says, "Oh, that's just a theory," they mean it's a hunch, a guess. But when a scientist says something is a theory, they're saying it is the most robust, predictive, and evidence-backed explanation we have. Calling something like evolution just a theory is like calling Mount Everest just a hill. It completely misses the power and the scale of what you're describing.
But you know what's maybe the coolest part of all this? Science isn't afraid to be wrong. In fact, that's its superpower. Theories are meant to be challenged. The theory that the Earth was the center of everything was replaced by a better one. And hey, even the great Einstein himself had a theory that the universe was static that was eventually replaced by the theory of the expanding universe when better evidence came along. And that's not a failure, that's progress. That's the entire point.
And all of this leaves us with one last kind of thrilling question. A scientific theory is our best understanding of reality, right here, right now. It's the strongest word we have. But the story of science is never, ever finished, which really makes you wonder, doesn't it? What accepted idea of today is just a stepping stone to an even deeper, more amazing truth that we haven't even discovered yet?